Power stations produce electricity which we use at home and to drive our economy. Today we're going into the Koeberg Nuclear Power Station near Cape Town for a look at the way that they produce electricity from nuclear power. A power station produces steam, which drives a turbine, and the turbine rotates the shaft of a generator which generates electricity. There are various types of power stations around the world, using coal, oil, natural gas and nuclear power. All of these heat up water to create steam that will power the generators. At the Koeberg Nuclear Power Station, there are two huge reactor buildings, each containing a nuclear reactor. Within the reactor core, fuel rod assemblies house uranium that is responsible for the generation of heat. Each fuel rod is filled with uranium-235 pellets. A number of these rods are placed into a fuel assembly. About 157 of these fuel assemblies are then placed inside the reactor vessel and make up the core of the reactor. The reactor vessel is then filled with demineralized water. The energy required to make the steam is produced by splitting the nuclei of uranium-235 atoms. If you fire a neutron at the nucleus of a uranium atom, you'll cause the nucleus to split, giving off heat, energy and more neutrons, which in turn can be absorbed by new nuclei. This is called a chain reaction, and the process is known as nuclear fission. The fission process, and therefore the amount of heat generated inside the reactor, is controlled by lowering or raising control rods in the reactor. These control rods absorb the neutrons that are produced during fission. If you want to slow down the process, you insert a lot of control rods, and the chain reaction slows down or stops. The energy released by the fission process heats the water in the reactor to about 320 degrees Celsius at a very high pressure of 15.5 megapascal. This high pressure prevents the water from boiling and turning into steam inside the reactor vessel. The pressurized hot water flows through a network of pipes and heats demineralized water in a second chamber called a steam generator. There the steam is generated to drive the turbines. This two-chamber design minimizes the risk of radioactive steam reaching the turbines and being discharged into the environment. The steam is ducted through enormous pipes and goes through various processes on the way to the turbines. As it passes over the blades within the turbine, the shaft of the turbine begins to rotate. The shaft is attached to an electricity generator, and 24,000 volts of alternating current is generated. Once the steam has passed through the last set of turbines, it flows over a set of cooling pipes filled with water from the sea. Steam is thereby condensed into water, and the water is pumped back to the steam generators for the process to start again. The water that is used to cool the steam at Koeberg is pumped from an intake basin on the Atlantic Ocean. Each pump is able to pump 20 tons of seawater every second into the power station. Rake screens, as well as large rotating drum screens, remove any debris and kelp that can clog the pipes. Station transformers, responsible for stepping up the potential, then increase the electrical output to 400,000 volts before the electricity enters the national grid. So to summarize, water is heated to 320 degrees Celsius in the nuclear reactor. This water heats water in a secondary chamber to boiling point. The steam from the boiling water is used to turn a turbine. The turbine drives a generator which generates 24,000 volts of electricity. Finally, station transformers step up the voltage to 400,000 volts, and this electricity is used in the electricity grid. There are 435 nuclear power reactors in operation in 31 countries around the world. Construction of the Koeberg power station started in 1976, and and the electricity output from the power station was synchronized to the national grid in 1984. It is currently the only commercial nuclear power station in South Africa and the sole commercial one on the entire African continent.